what are the figure of repulsion and the geometry for the other forms AXM, EN. To note that for AX2, AX3, AX4, AX5, and AX6, the figure of repulsion is the same as the geometry, since the non-bonding pair is equal to 0. Now we pass to other possibilities of AXM, EN. In this table, we have the electron groups, the bonding type, the lone pairs, the electron geometry, which is the figure of repulsion, the molecular geometry or the molecular shape is simply that geometry, the angles, and the form, the ball and the stick form. Suppose I have a structure of the form AX2E0. That means around A I have two outer atoms, and the bonding pair is 2, since I have two outer atoms. The lone pair is 0, so the figure of repulsion of EP equal 2 is linear, the geometry is linear, and the angle is 180 degrees. This is the Lewis structure, and this is the drawing of the geometry according to the balls and the stick method. Consider BF3. BF3, so the form is A. First you have to draw Lewis. We draw Lewis, we find the form AX3 E0. So we have 3 outer atoms. EP equal 3, NBP equal 0. For EP equal 3, the figure of repulsion is a trigonal planar. And since we don't have NBP, so the figure of repulsion is the same as the geometry. The angle is equal 120 degrees, and this is the ball and stick geometry. Consider SO2 molecule. First, draw Lewis according to the steps. Pay attention, we have to follow the steps in the written of Lewis structure, since any incorrect Lewis structure means incorrect geometry. So this is the Lewis structure. The form is A, X2, we have 2 oxygen, E1, A, X2, E1. The EP is equal to 3. In this EP, we have 2 bonding pairs, so this is BP, and 1 non-bonding pair, so NBP equal 1. The figure of repulsion of AX2E is the same as AX3. The figure of repulsion is the same as AX3, but we have 2 lobes for AX and 1 lobe for E. So since the figure of repulsion is the same as AX3, so the figure of repulsion is trigonal planar. Trigonal planar. We have 2 lobes for AX and 1 lobe containing 2 electrons non-bonding. Now we have to pass to the geometry. If we erase the non-bonding pair, we obtain AX that form a geometry which is band. And for band, we have to know that the angle is less than 120 degrees. Consider CH4. The form, the Lewis, is the following. So the simple AXMEN is AX4E0. What is EP? EP equal 4. What is BP? BP equal 4. Don't have lone pairs. So AX4 has a figure of repulsion tetrahedral, and since we don't have NBP, so the figure of repulsion is the same as the geometry. This is the tetrahedral form, and the angle is 109.5. Consider NH3. We draw NH3. This is the Lewis. So the form is AX3E1. AX3E1, EP equal 4, BP equal 3, and BP equal 1. Since EP equal 4, so the figure of repulsion of AX3E is the same as AX4. So the figure of repulsion is tetrahedral. We have 3 lobes AX and 1 lobe in the tetrahedron containing 2 electrons. Now we have to pass to the geometry. So we have to erase 1 lobe of CH4. If we erase 1 lobe of CH4, we obtain this form. So this form look like a pyramid where the basis is triangle. So the geometry is triangle pyramid, or pyramid triangle, or simply trigonal pyramidal, and the angle is less than 109.5. Consider H2O. Draw Lewis. This is the best form. AXMEN is identical to AX2E2. AX2E2. EP, we count all pairs, so EP equal 4. In this EP equal 4, we have 2 bonding pairs and we have 2 non-bonding pairs. So what is the figure of repulsion? The figure of repulsion of AX2E2 of EP4 is the same as AX4. So the figure of repulsion is tetrahedral. We have 4 lobes that make a tetrahedron, 2 lobes for AX and 2 other lobes or other balloons, each containing 2 electrons. So the figure of repulsion is tetrahedral. Now we have to pass to the geometry. We erase 2 balloons. So we obtain a shape. When we erase 2 balloons, we obtain this shape, and the name of this shape is band, and the angle is less than 109.5. Now we pass to PCl5. We write Lewis. This is AX5E0, EP equal 5. In this EPs, we have BP equal 5 and NBP equal 0. We don't have lone pairs. So the figure of repulsion of AX5 is, as you know, trigonal bipyramidal, and the geometry is also trigonal bipyramidal since the figure of repulsion, since we don't have NBP. We have 2 types of angles: equatorial 120, axial 90, and axial since they are perpendicular to the plane, so the angle axial is 180. X4E like SF4. We write Lewis, we obtain the structure. Look to the central atom, which is the sulfur. This is AX4 E1. A, X4, E1. So EP equal 5. In this EPs we have BP equal 4 and NBP equal 1. So what is the figure of repulsion of AX4E? The figure of repulsion of AX4E is the same as AX5. So we have 5 lobes, 4 lobes for AX, and 1 lobe containing the lone pair. So the figure of repulsion is the same as AX5. This is trigonal bipyramidal. Now we have to pass to the geometry. We have to erase the NBP. If we erase the NBP, as we said previously, the bonding pair is found in the plane, in the equatorial place. So we erase 1 lobe in the plane. We obtain this geometry, and this geometry is called seesaw. So the equatorial is less than 120, and the axial equatorial is less than 90. BRF3. BRF3, we write Lewis. We obtain the form AXMEN as AX3 E2. AX3 E2. So EP equal 5, BP equal 3, and BP equal 2. What is the figure of repulsion of AX3 E2? The figure of repulsion of AX3 E2 is the same as AX5. We have 5 lobes, 3 lobes for AX and 2 lobes containing H1 pair of electrons. So we have 5 lobes. As I said previously, the lone pairs in the AX5 type prefer the equatorial. So we have 5 lobes. In the plane, we have 2 lobes containing the lone pairs, and the 3 other lobes, 2 axial and 1 equatorial. So now we have to erase the non-bonding pairs. Okay, we obtain this structure, and this structure is like T. So the geometry now is T-shaped, and the angle is approximately or less than 90 degrees. We pass to xenon F2. Xenon F2, AX2 E3. So EP equal 5. In this EP equal 5, we have 2 BP and 3 NBP. And as I said, the NBP prefer the equatorial. So we have in the plane 3 lobes containing H2 electrons, and in the two outer are perpendicular to this plane. So in the plane, we have 3 lobes containing H2 electrons, and the 2 outers are axial, are perpendicular to the plane. Now we pass to the geometry. We erase the NBP, and the geometry is therefore linear, and the angle is 180 degrees. We pass to SF6. SF6, the form is AX6E0. So AX6. AX6, EP equals 6, BP equals 6, and BP equals 0. We don't have lone pairs. So the figure of repulsion of AX6 is the same as the geometry, and this is octahedral, and all angles equatorial or axial equatorial are equal to 90 degree, and axial is equal to 180. We pass to BR F5. BR F5, this is AX5E. I explained it before. AX5E, EP equals 6, BP equals 5, and BP equals 1. The figure of repulsion of AX5E is the same as AX6, so octahedral. So we have 6 lobes, 5 lobes in the plane, and 2 lobes perpendicular to the plane. And I said that in the AX6, the lone pair prefer the axial. So AX5E, we have 4 lobes in the plane for AX. We have 1 lobe perpendicular to the plane containing E. So the geometry is to erase this lone pair, and the geometry is pyramid square. And the last structure is xenon F4. The lowest is AX4 E2, EP equals 6, BP equals 4, and BP equals 2. So the figure of repulsion of AX4 E2 is the same as AX6. The figure of repulsion is octahedral, and the 2 lone pairs are outside the plane, are perpendicular to the plane. One perpendicular to the plane, and the second is also perpendicular to the plane. To pass to the geometry, we have to erase E, and we obtain this form, which is simply a square planar, and the angles are equal to 90 degree. So this is all types AXM EN. I will try to make an abstract for this method. I give you the molecule, you write Lewis, you transform the Lewis structure according to Lewis, you transform the molecular formula to the type AXMEN as a rule. If you don't have E, the figure of repulsion is the same as the geometry. If you have E, you draw it as a bond, as a lobe. But this lobe is not a bond AX, this is a lobe containing 2 electrons. Then, to deduce the geometry, we have to draw the figure of repulsion first. And pay attention, in the figure of repulsion, we draw all types of the electron pairs EP. So we obtain a form: linear, trigonal planar, tetrahedral, bipyramid triangle or trigonal bipyramid, and the last one is octahedral or bipyramid square. The figure of repulsion is one of these types. Pay attention. Is one of the 6 arrangements. Now we have to pass to the geometry. After we draw the figure of repulsion, we have to know the place of the lone pair. Pay attention. In EP5, the lone pair are found in the plane. For EP6, the lone pair are found outside the plane. So now we erase in all the 6 arrangement, we erase the lone pair. We erase the NBP, the non-bonding pair. So we obtain a certain form, and this form is the geometry. I will do an example. Example 3.4. Predict the molecular geometry and the bond angle in SiF5 minus. So first of all, I have to write Lewis structure. And in Lewis, we have to follow the rules. What are the valence electrons? Silicon, 4 electrons. F, 7 electrons. And we have minus, pay attention, 1 minus in addition. So the total valence is equal to 4 plus 5 times 7 plus 1. So we have 40 electrons valence. Now we draw the Lewis structure by following the rules. Choose the central atom, which is Si. Join the central to the outer atom. Then distribute the remaining valence electrons on the outer. If the central need more electrons to have the octet rule, you have to transform one lone pair, one NBP, non-bonding pair, from the outer atom to bonding pair. So the Lewis structure is Si, the central, and we have around 5 atoms. So 2, 4, 6, 8, 10. So we have 40. Minus 10, we have 30. Remained electrons are distributed on the 5F. So this is the Lewis structure for SiF5, and pay attention, we put the brackets minus as notation. This minus is a notation. It's count before in the total valence electron. So now, what is the form of AXMEN? This is AX5E0. AX5 we have to correct. This is AX5E0. So we have 5 bonding pairs and 0 lone pair. So EP equal 5, BP equal 5, and NBP equal 0. This is AX5E0 and not E. AX5E0. We have to correct. So now what is the figure of repulsion of AX5E0? The figure of repulsion is one of the 6 arrangements: linear, trigonal, planar, tetrahedral, trigonal bipyramid, or octahedral. So AX5 is bipyramid, triangle or trigonal bipyramid, and since we don't have E in NBP, so this is AX5E0, then the geometry is simply trigonal bipyramidal. What are the angles? In the trigonal bipyramidal, equatorial 120, axial equatorial 90 degree. Another example, predict the molecular geometry and the bond angles in ClO2F. First of all, we have to choose the central. The central is, by theory, is oxygen, by theory. But since we have two oxygen, in this exercise, the central should be, by theory, oxygen, since oxygen has 2 electrons. But he gave me a notation that the oxygen is not the central atom. So the central atom is Cl or F. And since Cl is less electronegative than F, so the Cl is the central. Pay attention, as I said, in this exercise, the oxygen by theory should be the central atom. But he gave me indication that in this structure, we have exception. The central atom is not the oxygen. The central is Cl or F. I have to choose which is less electronegative, so the central is Cl. Cl has 7 valence. So oxygen, we have to correct. The oxygen has 6 valence. This is typed incorrectly. So the Cl is 7 electrons, the oxygen is 6 electrons, and the F is 7 electrons. So now I correct. So the valence electrons is 7 for Cl, plus 2 times 6 for oxygen, plus 7 for the F. So we have 26, and the Lewis structure is the following. So what is the form AXMEN? This is AX3E. AX3E, the figure of repulsion is as AX4. So the figure of repulsion is tetrahedral. And we have one lobe here containing the non-bonding pair. So now we pass to the geometry. We erase the non-bonding pair. We obtain this AX3. So the geometry is like a pyramid, and the basis is a triangle. So this is trigonal pyramidal. And the bond angle is less than 109.5